What is a titration? A titration is a technique where a solution of a known concentration is used to determine the unknown concentration of a solution. Usually, the solution of known concentration or titrant is added from a burette to a known quantity of the analyte, the unknown solution, until the reaction is complete, which is indicated by the endpoint. The accuracy of the results of your titration will be a reflection of the care you took while performing it. When done carefully, titrations give very accurate, precise results. Here is a step-by-step procedure required for performing successful titrations. The burette has now been cleaned and prepared as shown in the previous videos. The meniscus is level with any graduation mark on the burette between 0 and 2 milliliters. The initial reading will be recorded, remembering to do it to 2 decimal places. The analyte solution is pipetted into the conical flask and then a few drops of the indicator is added. The conical flask is then placed under the burette. When performing the first titration, the solution is delivered at a rapid pace to get a rough idea what volume is needed to reach the endpoint. This is known as a rough titration, and it is not included in your final results as it is not accurate. However, you still need to record the final volume reading from the burette. The volume of solution delivered is determined by subtracting the final reading with the initial reading. The burette will then be refilled. Initial readings recorded and the solution in the conical flasks prepared in preparation for the next titration. The next titration will be done carefully to ensure that the endpoint is not missed using the volume recorded during the rough titration. The general procedure is to deliver approximately 3/4 of the volume of titrant recorded from the rough titration at a rapid pace and then add the titrant slowly until the endpoint. It is even possible to add a drop, swirl, add another drop, and so on until an endpoint is reached. When approaching the endpoint volume, a good habit is to wash the sides of the conical flask with distilled water from a wash bottle, as when swirling, the side of the conical flask will touch the tip and some of the titrant will stick to the walls of the flask. If there is a droplet hanging on the tip of the burette, wash the droplet into the flask using a wash bottle, especially when approaching the endpoint. Washing off the titrant will result in a more accurate and precise result. Once the endpoint is reached, the final reading is taken and the total volume of titrant delivered is determined by subtracting the final reading from the initial reading. Titrations are generally done in triplicate, so you will need to perform 2 more titrations. To get precise results, your volume of titrant delivered for the 3 non-rough titrations should be 0.1 milliliter difference between each titrant volume delivered. If this is not the case, additional titrations will be performed to get precise results. To better observe the color change of the indicator, a plain white piece of paper is placed under the conical flask. For right-handed individuals, the burette tap will be handled using your left hand, while the flask is swirled with the right hand. However, for left-handed individuals, the burette tap is handled with the right hand and the flask swirled using the left hand. In this case, the left-handed individuals will have to reverse the burette to accommodate their titrations. Here is the summarized procedure required for successful titration. Step 1. If the sample is a solid, it is weighed and then dissolved to make up a known volume of solution in a volumetric flask. Step 2. A pipette is used to measure accurately a volume of the solution, for example, 10.00 milliliters. This is emptied into a conical flask. Step 3. A few drops of an indicator may be added to the conical flask. This will show a change of color once we have reached the endpoint or when the titration is complete. The following indicators will be used in your practicals. Step 4. A second solution is placed in a burette. This is the titrant. This solution contains a chemical that will react with the analyte chemical sample in the conical flask. Step 5. The solution from the burette is run into the conical flask. The solution is added 1 drop at a time and swirled to mix the solutions as the endpoint is approached. Eventually, a color change shows the correct amount that has been added to react completely with the analyte chemical in the sample. Step 6. The volume of solution added from the burette is noted. The titration results can then be used to calculate concentration. Using the following steps ensures that your titration experiments are carried out using the correct techniques that enable you to get precise and accurate results.